This is Dr. R. Ramya Swetha, Assistant Professor, Civil Engineering Department from Institute of Aeronautical Engineering. Today our topic is specific energy in open channels. Coming to the specific energy, these are the web references which I consider for the energy, specific energy. The first we have to understand the specific energy in non-uniform flow. Coming to the non-uniform flow, already we know in non-uniform flow, we have two different types of classification, two different categories for non-uniform flow. The first one is gradually varied flow and the second one is rapidly varied flow. Gradually varied flow. Second one is rapidly varied flow. These two are subcategories for non-uniform flow. So in this, along the length of the channel, the velocity, slope of the channel bed, velocity, area of cross-section, cross-sectional area, along the length of the channel, these are varying with respect to depth. So that is nothing but the non-uniform flow. In that gradually varied flow, it changes gradually in the depths are gradually changing along the short length of the channel. In same short length of the channel, the variations occur very abruptly, very rapidly. Such type of flow is known as rapidly varied flow. Why? What are the causes for non-uniform flow? Differences in depth of the channel and differences in the width of the channel, differences in the nature of the bed, differences in the slope of the channel, and any kind of obstructions will happen in between the direction of the flow. So these are the causes for getting non-uniform flow in channels. So in this, coming to the specific energy, total in specific energy, total energy is equal to Z plus H plus V square by 2G. In this, Z is the datum head, H is the potential head, potential energy, V square by 2G belongs to kinetic energy, where Z is the datum energy, datum head, H is the potential head, potential energy, V square by 2G is the V square by 2G is the kinetic energy. The sum of all the energies is nothing but the total energy. Sum of the all energies is nothing but total energy. Coming to the specific energy, the potential energy plus the kinetic energy, the sum of the potential energy and the kinetic energy, which is called as specific energy. In this specific energy, we can observe, so this is the datum line, consider the datum line, this is the channel bottom, this is the bottom of the channel, this is the datum head, this is the depth, this is the datum line, it is a straight line, datum line, DATUM, datum line, this is represents Z, and this is the channel, bottom of the channel, and H represents the depth of the liquid, depth of the flow of the liquid. In most of the cases, the liquid is nothing but the water, and this is the dotted line represents this is nothing but the kinetic energy. This is V square by 2G. This is the free surface from here. From this, the free surface. Like this is the channel bottom. The combination of three is nothing but the total energy. We are considering potential energy and kinetic energy, that is nothing but the specific energy. Specific energy. From based on these, we are understanding the specific energy equation, curve equation. So coming to the discharge, we know discharge is equal to area into velocity. So velocity is equal to, if in this area and velocity, V is nothing but the mean velocity, H is nothing but the depth of the flow. In some of the references, they may use Y also for depth of the liquid. For depth of the liquid, in some of the textbooks and some of the references, they may consider Y. It is the notation variation only. No need to bother. So it depends upon the whichever is convenient for us, we may consider that particular notation for the depth of the flow. So now coming to the discharge and this small q. Q is nothing but the discharge per unit width. Per unit width. Coming to the capital Q is nothing but the discharge of the channel flow. Discharge of channel flow. This is the difference between these small q and capital Q. In this specific energy, we particularly consider small q as a notation, that is nothing but the discharge per unit width, and coming to the capital Q, that is the discharge of the overall channel. So from this Q by B. So discharge per unit width, Q is equal to capital Q by, it is constant we are considering. So from this, velocity V is equal to, we know discharge is equal to area into velocity. It means velocity is equal to Q by area. But here what we consider, Q is equal to, small q is equal to capital Q by width of the channel. It means Q is equal to Q into B. Discharge per unit width multiplied by width of the channel. So substitute those two in this equation. So Q is equal to Q into B by area. Area is nothing but, this is area. That is nothing but Q by B by area is nothing but B into H. Cancel those two, finally Q by H. V is equal to mean velocity of flow. V is equal to Q by H. Q by H. This is not V. This is H. Q by H. That is nothing but discharge per unit width by the ratio between the discharge to the unit width per height of the or depth of the liquid. Depth of the water flow or depth of the liquid gives the velocity of the flow in specific energy. So this is nothing but the, so already we know E is equal to, specific energy is nothing but E is equal to H plus V square by 2G. Potential energy plus kinetic energy. In this, substitute the velocity V in terms of discharge per unit width. So that gives H plus Q square by 2G H square. This is the modified specific energy equation. Using this, the variation of the depth, the curve will occur. This is nothing but the specific energy. Now move on to the specific energy curve. We will get this curve. So from this, in this, x-axis represents the specific energy. Specific energy. This y-axis represents, along the y direction, it represents the depth. Depth of liquid or depth of water flow. So in this, we are going to plot x-axis. In x-axis, specific energy curve, along the y-axis in depth of the liquid. Coming to the specific energy curve, this is specific energy and this is depth of the flow. Now the first one is the potential energy, which is a straight line which passes from origin and it makes an angle of 45 degrees. It is a straight one which is makes an angle 45 degrees with the origin. So this is nothing but the EP potential, that is equal to H. And the second one is V square by 2G, V square by 2G or Q square by 2G H square. That is nothing but the kinetic energy. It represents the kinetic energy. The curve should it should be like this, parabolic. The shape is parabolic. Those two are not going to touch. So this is Q square by 2G H square. That is nothing but the E kinetic energy. This is the represent. The both together is nothing but the our specific energy curve. It is like this. The combination of those two, the combination of potential energy and the kinetic energy. This is nothing but the E specific energy, or E specific energy is equal to H plus Q square by 2G H square. This is the shape is like this. In this, we may observe alternative depths. Whenever the depth of the flow, so whenever it is considered like this. So this is HC critical depth and this is H1 and this is H2, alternative depths. So it represents this critical flows, subcritical flow and supercritical flow. We will discuss in our next slides. So this is the specific energy curve. This is the specific energy curve. The combination of the potential energy and the kinetic energy. So those two, the combination of these gives the specific energy curve. This is the final specific energy curve. Specific energy curve. Now next, critical depth. So critical depth is nothing but the depth of the flow of water at which the specific energy is minimum. Whenever the specific energy is minimum, that such at particular depth, the correspondent is known as the critical depth. So coming to the critical depth, first we have to understand how we will get E specific energy is equal to, we know this is the equation. So EH plus Q square by 2G H square. 2G H square. So in this, we are understanding the critical depth. The depth of flow at the specific energy is minimum. So whenever the specific energy is minimum, that is nothing but the specific energy is differentiate with respect to depth of the liquid. That is H. The specific energy is going to differentiate with respect to H because the specific energy is minimum, and it means mathematically we may express like this: the dES by dH is equal to 0. So now substitute this differentiation with respect to X, that is equal to H plus Q square by 2G H square. In this, Q square by 2G is a constant one. Q square by 2G is equal to constant. So now this is 1 plus Q square by 2G is constant. Coming to the H square, that is minus 2 by H cube, that is the differentiation from our mathematical expression, that is equal to 0. That is equal to 0. Now 1, this is going to cancel, minus Q square by G H cube is equal to 0. It means Q square by G H cube is equal to 1. it is belongs to critical depth and it denotes in terms of HC, the depth of flow at minimum specific energy. We call it as critical depth. So HC is equal to HCQ. This is HCQ is equal to Q square by G. So HC is equal to Q square by G whole the power of 1 by 3. This is the final answer we will get. So this is the procedure. So based on the definition, we are done the derivation part. This is the way to derive the depth of the flow of water at which the specific energy is minimum. So based on the specific energy equation with respect to the H, so specific energy is minimum with respect to the H, the differentiate with respect to H the specific energy equation. Finally, we will get the HC is equal to Q square by G whole the power of 1 by 3. This is the critical depth. Now next move on to the critical velocity. For critical velocity also, we have to use the, whenever the critical depth is known as, whenever the velocity of the flow at correspondence of the critical depth. So the particular point where the critical depth is there, that exact correspondent gives that velocity is nothing but the critical velocity. That velocity is nothing but critical velocity. Now we know, already we proved this one, HC is equal to Q square by G whole the power of 1 by 3. This is HC is equal to Q square by G whole the power of 1 by 3. So now HC is equal to Q square by G whole the power of 1 by 3. So this is the thing we are considering. So now HC cube is equal to Q square by G. Already we know in terms of velocity, here this is the discharge per unit width, but the requirement is in terms of velocity. That's why we are converting. We know discharge is equal to area into velocity. Discharge is equal to area into velocity. This small q is equal to discharge per unit width is equal to discharge of the channel per width of these. So now q into b is equal to area into velocity. So velocity is equal to q into b by area. We know q, keep like this, b is like this, area is nothing but b into h. Finally v by h is there. V is equal to q into v by h. Now this hc cube is equal to v into h is equal to, this is nothing but v into h is equal to q from the expression. Now q is equal to, in terms of, here the requirement is in terms of velocity, that's why we are doing like this. This is the procedure. So now q, substitute the value of q in terms of q square. Now hc cube is equal to, q square is nothing but v square h square by g. So cancel this one. It is in terms of hc is equal to v square by g, that is nothing but v square is equal to gc into h. V is equal to root g hc. This is the answer we will get. Like this we are going to derive. We know the required in terms of velocity. So we know discharge is equal to area into velocity, and discharge per unit width is equal to discharge of the channel per unit width, and substitute the values. Finally q in terms of velocity and substitute that value in critical depth. What we get in the value. Finally we will get the velocity is equal to root 2g hc. This is the critical velocity. Next, minimum specific energy in terms of critical depth. How we will get the minimum specific energy in terms of critical depth. So coming to the minimum energy, it is depends upon the how the depths are going to vary. So coming to the minimum depth, E is equal to, we know E is equal to, in terms of critical depth actually it is E is equal to h plus q square by 2g h square. This is our previous equation. Please check it. This is our standard equation. Based on that only we are doing as per the definition, we are deriving the other equation based on the statements. So E is equal to H plus Q square by 2G H square. So minimum specific energy in terms of critical depth. Minimum specific energy in terms of critical depth. So E is equal to, this is Hc plus we know Q square by V is equal to, the Hc is equal to, we know Hc is equal to Q square by G, Q square by G whole 1 by 3, and we know another one is, that is equal to Vc is equal to root GHc. We know these two. Okay, now Hc, Q square. Q is nothing but the, in terms of Hc, we required in terms of Hc. So Q in terms of Hc. So we will do this. So what will happen? Hc is equal to Q square by G. It means Q square by G, this is 1 by 3, whole the power of 1 by 3. So now H3 cube is equal to, from critical depth, this is the thing. So now Q square by G is equal to Hc cube by 2 into H square. So now cancel this one. So Hc plus Hc by 2, that is nothing but the 3Hc by 2. This is the derivation we will get. This is the derivation we will get. This is the minimum specific energy in terms of critical depth. So minimum specific energy in terms of critical depth. So based on the critical depth equation, we are substituting this in terms of we required terms of the. So this is the specific energy, minimum specific energy in terms of critical depth. So this is the equation we will get. So E specific energy minimum is equal to 3 by 2 times of the critical depth. That gives the minimum specific energy. So the next one, already we discussed critical depth. So whenever the critical depth, the corresponding flow is nothing but critical flow. We are understanding those terms in detail. So critical flow, it is critical flow at which the specific energy is minimum, or the flow corresponding to the critical depth is defined as the critical flow. That is equal to Vc is equal to root 2h Gc. Already we proved in terms of velocity, V by root 2 GHc. So this is V. Root GHc. Vc is equal to root GHc. Now V by root GHc is equal to 1. So this represents the Froude number. This is nothing but the Froude number. It means that whenever the Froude number is equal to 1, Hc, exact that flow, that is nothing but the critical flow. That is nothing but the critical flow, that is in this one. So whenever this is the thing, this is the critical depth Hc. Now whenever another flow, whenever the Froude number is less than the 1, the Froude number is less than the 1, such type of flow is known as subcritical flow. Whenever the Froude number is less than 1, V by root GHc is less than 1, it means the critical depth, this is not critical depth at that time. So whenever the critical flow is there, that is called, so the equation is root 2gh is equal to 1. So this h is equal to Hc. This h is equal to Hc. Depth of the flow is equal to the critical depth. So in that particular case, the flow is known as critical flow. The flow is known as critical flow. Coming to the V by root GH, it is less than 1. It means the Hc, the critical depth is at that particular point, the depth is more than the critical depth. So this is more than the critical depth. So such type of is known as subcritical flow. So whenever that is nothing but that is subcritical flow. Similarly, whenever the Froude number is more than 1, such type of flow is known as supercritical flow. Froude number is more than 1. So here the critical depth is less than the depth of the flow. So critical depth is the less than the depth of the flow. Such type of flow is known as subcritical flow. In this, the Froude number is more than 1. Coming to the subcritical flow, the depth of the flow is greater than the critical depth. Such type Froude number is less than 1. Such type of flow is known as subcritical flow. Based on the Froude number, we are going to identify the which type of flow it belongs to. So whenever the V by root 2 GH is equal to 1, such type of flow is known as critical flow. V by root 2 root GH is less than 1, such type of flow is known as subcritical flow. V by root GH is greater than 1, such type of flow is known as supercritical flow. It is depends upon based on the critical depth. Now, condition for maximum discharge for a given value of specific energy. We know specific energy E is equal to H plus Q square by 2GH square by H square. This is the formula. This is the whenever we start from based on this formula, standard specific energy equation. E is equal to H plus Q square by 2GH square, that is nothing but the H represents the potential energy and Q square by 2GH square is represents the kinetic energy. The combination of the potential energy and the kinetic energy is nothing but gives the specific energy. Coming to the maximum discharge Q is equal to discharge Q, total channel discharge, flow rate of the total channel. So this is nothing but, so our small q is nothing but Q by B. Now Q is equal to into B. So now ES is equal to H plus Q square by 2G H square, maximum discharge with respect to the X also. So now first we have to write in terms of Q in terms of small q in terms of capital Q. So ES is equal to ES substitute small q in terms of capital Q. Q square by 2G B square H square. So here like this Q square is equal to Q square B square. Substitute the small q in terms of capital Q. So now maximum discharge with respect to H, differentiate with respect to H is equal to 0. H plus Q square by 2G B square H square is equal to 0. With respect to H, D by dH. This is equal to 1 plus this Q square this Q square by 2G B square H square is equal to, with respect to the H is equal to 0. In this E for maximum discharge for value of the specific energy based on the specific energy. This is also finally done the derivation. Finally we will get 2 into H. So those two are the same equations. Finally we will get for this condition of the maximum discharge value in terms of specific energy also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.